Hi US, this is Balakrishna physics classes. Again, we are going to discuss refraction through prism from BKR classes that I am going to explain with a small slide. Therefore, it is very clear for you. That is, what is a refraction? We know that we have studied refraction is a phenomena of bending of a light whenever it has crossed a medium. So, we know that at the same time it follows the Snell's law while it is refracting. What do you mean by Snell's law? Snell's law is nothing but ratio of when a light is passing from medium 1 to medium 2, the ratio of sine of angle of incidence in the medium 1 to the sine of angle of refraction in the medium 2. That we know, right? So now we are going to discuss refraction through prism, how it will take place usually. Refraction through prism. Okay. Now, this refraction through prism, I am going to discuss. We know that first, what is a prism? The prism dimensions. Usually, the prism, which is we call as a, uh, transparent medium. Okay, the transparent medium, which is combination of three rectangular surfaces. Three rectangular surfaces. This is one. This is two. Behind this, there's one. Three rectangular surfaces, two equilateral triangular surfaces. This is one and this is one. So by combining two equilateral triangles and three rectangles, it is made up of a one transparent surface that is be called as prism. Now, if when a light allowed to pass, when a light allowed to pass, here we are taking the light source, which is a monochromatic light. Which is called monochromatic light? The light is having single wavelength or single colored light we called as monochromatic light, right? So when this monochromatic light allowed to pass, then how it will refract through prism that we are going to discuss. What is the refractive index of the prism that we are going to derive now in this slide, in this video. Okay. So, sir, why you are preferring monochromatic light only, sir? Why won't you take that white light? Yes, if you take the white light, what will happen? We know when a white light allowed to pass through the prism, white light is having the combination of its constituent colors. So due to that colors, what will happen whenever it is entered, it will go on a dispersion process. So whenever it will go on a dispersion process, of course there is a deviation, but you need to identify only properly the refractive index of the prism and minimum deviation of the prism in the sense better if you are using single wavelength light. Then with single light ray you can understand very clearly. Then the n number of different color light. Okay. So now if we enter refraction through prism, we understood what is a prism. Okay. Now we need to know refraction to prism. We need to understand in a sense. We need to have some basic mathematical knowledge. As a physics student, science student, everyone, they should have some basic mathematical knowledge. That is the refracting surfaces, which we are seeing. When a light allows, how the light refracts, how it will bend. They are showing like a one sample picture. So this is a prism is having the refractive index mu, which we are considering, and angular prism A. When a monochromatic light allowed to pass through it, it will bend towards its normal. Look at this. This is, if you draw normal, towards this normal it is bending. Nothing but it's supposed to go like this if there is no prism, but it is refracting towards the, or it is bending towards the base of the prism. The same manner, the second refraction also is bending towards the surface, right? So this is normal one, this is normal two, you can see. Since this is normal one, we know that in any refraction, when we are making an angle with the normal that we call as angle of incidence, when we are making with the normal uh, while light ray is refracting that we call as angle of refraction. Usually at first refracting surface here we are having the angle of refraction, this R1. And at the second refraction surface, the incident light ray we are taking at this portion R2. And the light here which is emerging out, okay, so it's going out at the second refracting surface, so we call emergent light ray. Since it is going out, instead of refracting angle or refracted ray, I can say here that is, since it is going from the denser medium, so I can call it is emergent light. Okay, emergent light ray. This angle is called as emergent angle. This is a R1. R1 is a, just now I told that is taken as first refracted angle. R. This is a at second refraction surface. The incident angle R2 is a point O which we have taken between these two normals wherever it will meet. There is a vertex has formed that I am denoting as O. Now, just you notice this point. Just now I told if there is no prism, the incident angle could travel like this. The dotted lines will appear. And the emergent light ray, if you could expand it back, if you could expand it back, then there is a vertex will form between the extended incident light ray and emergent extended light back. So that angle we call, see here, angle of deviation. What is this? Wherever the light rays which are extended, that is incident and emergent light ray backwards, then there is a vertex will form, or those two light rays will meet at a point. This position is called as, this angle we call as angle of deviation. What is our deviation, sir? What is the meaning of the word of deviation? Deviation is nothing but changing the path of light from its original path. Usually, light ray is supposed to go like this. Since it is, we are place here prism. Due to placing of the prism, the light ray bending towards the base and is emerging out like this. Otherwise, light ray could go straight like this, right? So at this point, wherever these two external light rays will meet, that point we call as angle of minimum deviation. Angle of minimum deviation of that particular prism. Of course, this angle of minimum deviation depends on this incident angle. The way incident angle you change, the deviation angle will change. That is very common point. And apart from that, there is an angle of prism. Means angle of prism indicates indirectly the dimensions of the prism, right? If angle of prism changes, then deviated angle also may change. Now, see, let us enter into the actual derivation part. See, we are considering at the first incident point. First incident point, you are seeing point P, and second refraction position we are taking, that is as a Q. Okay. Now, apart from that, there is a point position we took D. What is the D? D is the position of the angle of deviation we took. Okay. Now, what is the need of this all taking, sir? So, to express it mathematically, we need to take some considerations as a different positions. Let us see now. In quadrilateral triangle There is a quadrilateral triangle A, P, O, Q. A, P, O, Q. This is a quadrilateral triangle. So APOQ is nothing but quadrilateral. It's looking like a little rhombus. There is a rule in quadrilateral triangle. The sum of opposite angles must be equal to 180 degrees. So it can be, it look like opposite angles supposed to 190 degrees, but when you are seeing in this diagram, here it may not looking, here it is little more less angle, here it is more angle, it appears. But common rule is that sum of these two supposed to be 180 degrees and sum of these two supposed to be 180 degrees. Okay, then the total it will become 360 degrees. So this is the actual rule of in quadrilateral triangle. So in the same manner, on the basis of quadrilateral triangle rule, we have here angle angle O plus angle A, opposite angles, is equal to 180 degrees. That is, we have taken as a equation 1. It's mathematical proof. We know that normal 1, normal 2 in the diagram. Next, after this, you are having the next one from the triangle OPQ. From where? Triangle OPQ. From this OPQ, we can write OPQ is a triangle in the sense sum of the angles in the triangles gives us 180 degrees. This is very clearly we know from the rules of triangle. Means if any triangle is said to be a triangle in the sense in that sum of those three angles must be equal to 180 degrees. So here angle R1 plus angle R2, angle 4 can be taken as 180 degrees. This is the equation 2. Now there is one more triangle also is there here DPQ. Okay, so DPQ. This is a one more triangle which comes due to extended like this. So from this angle R1 plus angle R2 plus O, this gives us 180 degrees that from the previous case. But in triangle DPQ, how it is? Here no angle, here no angle, but depends on the exterior angle, alternate exterior angle rule. This is for this is exterior angle with comparison of this is alternate exterior, these two, and for this is exterior angle. This one. Okay, alternate exterior angles we call this. So from that rule, we are taking by subtracting this and this the rest part of the angle how much it is. That is angular deviation delta equal to I minus R1. Then rest of the angle how much it is that will come. I minus R1 plus here emergent angle no E minus R2. E minus R2. So therefore, from the alternate exterior and interior angles rule, we got the deviation is equal to, this deviation is equal to I minus R1, E minus R2. So this is the equation third, most important equation. Now, from this triangle, here we are equation 1, equation 2, both are there, no? Already we obtained. From equation 1 and 2, I am adding LHS to LHS, RHS to RHS. Okay, adding or subtracting. So from equation 1 and 2, I got 180 is get cancelled and O it get cancelled whenever I do subtract. Then I have here angle of prism A equal to R1 plus R2. means that subtracted LHS to LHS, RHS to RHS. So when we have to do that, O get cancelled, 180, 180 get cancelled. So you have left angle of prism A equal to R1 plus R2 is a bar square. So that is this. Simply in a place of O, if you substitute, this is all A equal to R1 plus R2, you can obtain also. Okay. O equal to 180 minus A. In the place of O, if you substitute 180 minus A instead of adding subtracting, this is a better way easy. So after substitution by this, A and 180 is available here. 180, 180 get cancelled. You're having here angular prism equal to R1 plus R2 as a two. One is incident angle and another one is a refracted angle. This is a first step which we achieve in the refraction applied to prism. Now, from equation 3, we have obtained one more equation also from the rule of extended light rays and by the as alternate interior and exterior angles, right? Yes. You can see here delta equal, angle of minimum deviation equal to I plus E minus A. Now, that I plus E minus A from where it has come. Just simplification from equation 3. What I did here, I plus E, I have written separate minus R1 plus R2. We know from equation 1 and 2 got R1 plus R2 equal to A. In a place of R1 plus R2, I have placed here A. Therefore, I have an equation delta equal to I plus E minus A. So, I plus E equal to A plus delta. Now, we can write the sum of angle of incidence and angle of emergence is equal to the sum of angle of prism and angle of deviation we can write. Okay. So this is nothing but after solving from this equation only we can able to write. Right? Sum of angle of incidence and angle of emergence is equal to the sum of angle of prism and angle of deviation we can write. Now you can see here how the sum of angle of incidence and emergence has produced the angle of deviation, how it will change varying with the deviation with respect to incident angle. Just now, if obtain a graph, this is the incident angle. You can see here, this is the angle of deviation. So when I'll take at different angles, angle of incidence while I'm doing the practically, usually prism. So angle of incidence in this direction, angle of deviation in that direction. So I checked with the 35 degrees, 38 degrees, 40 degrees, 42 degrees, 45 degrees. So while I'm checking, I'll get the graph like this. So in this, what you notice by this type of slope, gradually it is decreasing. Later on, after a certain point, it has increased. Okay, after a certain point, it has increased. That means here at particular point, wherever it has stopped, that at this position, angle of incidence equal to angle of emergent. Okay, at this position, angle of incidence equal to angle of emergent. Then only minimum deviation comes. This position comes because of angle of incidence equal to angle of emergent. So that position we call as minimum deviation. Okay, or nothing but angle of minimum deviation. So that is graphically we can express after we have we did practical in practical case, but we did not have a practical values, no. So to achieve refractive index of the prism, we are considering out of maximum and minimum value. There is a minimum value. There is this is the only the minimum value. Again, it is gradually increasing. So between them, this is the actual minimum value. This minimum value we are preparing to find. So at this position, angle of incidence equal to angle of emergence. So you can see angle of incidence equal to angle of emergence. So delta m we called it as minimum deviation. What is that? Minimum deviation. So when angle of incidence increases, the angle of deviation decreases, gradually it has decreased. Now, at particular point, angle of incidence equal to angle of emergence that we call as angle of minimum deviation. So, if it is angle of minimum deviation on this condition, you can see here, you can see here in previous equation. What is the previous equation, sir? The previous equation is nothing but I plus E equal to A plus delta. I plus E means incident angle plus emergent angle is equal to angle of prism plus angle of deviation. From this equation, if you apply the minimum deviation rule, that is angle of incidence equal to angle of emergence. So we can able to write at minimum deviation angle of incidence equal to angle of emergence. Therefore, you can write R1 equal to R2 equal to R. Okay, means R1 and R2 are same. Then how the minimum deviation changes? That is A equal to R1 plus R2 become. So since R1 equal to R2, A equal to 2R it becomes, right? After became 2R, then I can write small r equal to A by 2. See, now I got angle of refraction R equal to A by 2. Okay. Now, from the same principle, angle of incidence plus angle of emergence equal to A plus delta. I'll substitute, and since angle of incidence equal to emergent in a sense, I can write in a place of EI also. So I have substituted if I here, then I'll get 2I here. So 2I equal to A plus delta. Now, what is I incident angle? What I did for that, I equal to A plus delta M by 2 I have written. So now I got refracted angle, incident angle. The condition of angle of incidence equal to angle of emergence that we call as angle of minimum deviation also, right? So now almost 95% we finished. Now just simple. What we are discussing, what is our actual topic? Our actual topic is that refraction through the prism, right? What do you mean by refraction here? Refraction is nothing but a phenomena of a light which is bending whenever it has crossed one medium to another medium at the boundary of media. So, so it is happen depends on the optical density variation of the two mediums, right? If when light ray passes from glass to water, glass to air, or air to glass. So by this way, we have there is a change in the path of light. Deviation takes place. The same thing is happen since prism is a glass material and we are allowing to pass from the light from the air medium to the glass. Therefore, there is a deviation has taken place. So, how much it has deviated, how much it has refracted, that we are going to find. So, for that, as from the laws of refraction, we have a great law. Mr. Our scientist has given Snell, that is Snell's law. What is Snell's law? We have discussed in starting of topic. Okay, Snell's law or refractive index also you can say. The refractive index is defined as sine of angle of incidence in the first medium to the sine of angle of refraction in the second medium. Okay, equal to constant for given pair of media. That we can say Snell's law refractive index. So mu equal to sine I by sine r. So in the place of I, what I am doing, in the place of I, I am substituting this value, a plus delta m by 2 by r. In the place of r, small r equal to a by 2, I am substituting. So sine r equal to, in the place of r, a by 2 I have substituted. Therefore, I have a refractive index of the prism, mu equal to sine of a plus delta m by sine of a plus delta m by 2 by sine a by 2. This is my refractive index formula for the prism. Okay, by using this prism particle also, we will find how it will vary, what is the refractive index of particular respective prism which is given. Okay. Now here one more small condition is also applicable. Let us say if the angular prism is smaller, angular prism, what is that? A. If E is smaller, if you consider, so these are the light rays. When we are dealing with the light rays, whenever it is refracting, the angle of incidence, angle of refraction, comparing with the normal view, is very, very, very smaller, right? And for the small prism, thin prisms, I mean, not very thick prisms. In the thin prisms, angular prism is smaller. Therefore, whatever the angle will come, just we will not take as a sine or cos or tan and all. That we are taking into the normal case because we are if you are not considering this sine because since it is a very thin angle, very thin prism, the angle is very, very minute or tiny. So, in such case, the refractive index we will take as A plus delta m by 2 by A by 2. Therefore, 2 get cancelled, 2 get cancelled. Then A I'll send that side, and I have A into mu equal to A plus delta m. Sine we will not use that time. Why? Since it is very smaller angle, it is there is no meaning of sine function, cos function if you are using also. Okay. So in such case, for small angle prism, you can see how instead of sine of angle of incidence by sine of angle of refraction, simply I by R1, E by R2 that we are writing. If in the formula, if you are substituting in such a way, I plus E equal to mu into A, so it will be I plus E equal to A plus delta. Now that can be also written A plus delta equal to mu into A. This mu into A we have substituted. Now if you rearrange this equation, then delta if you make as a subject, delta equal to A into mu minus 1. This is a angular deviation for thin prisms. Here we will not apply like any rule and all of angle of incidence equal angle of emergence, but still A plus delta equal to mu A. So from that we have applied delta equal to A into mu minus 1. Okay. Delta equal to A into mu minus 1 is applicable for only thin prisms which are having very, very small angles. Okay. This is all about the refraction through prism. Okay. Refraction through prism. Thank you very much. And please subscribe and share this video and give me value feedback of yours. Thank you.